The next type of compound inequality that we're looking at is compound inequalities using AND. So if you look at the notes, it says the solution is the region where both original inequalities are graphed. And sometimes this is referred to as the intersection. So we have x is greater than 2 and x is greater than 4. So let's graph both of those. I'm going to graph them actually above the number line. So 2 would be like that. X is greater than 2. And then x is greater than 4 would be like that. So we need to figure out where both inequalities are graphed. So if you look over here, there's nothing being graphed. If you look at here, only the bottom one is being graphed. Only the x is greater than 2 is being graphed. But if you look here, they're both being graphed. My vertical line hits both of those. And again, they want where both of them are graphed. So it's actually just here from 4 to the right where they're both graphed. So that'll be our solution. So 4 to infinity is our solution. Let's do another one. We have x is less than or equal to 6 and x is less than or equal to 2. So the 6, it's going to be a closed dot at 6, and I'm shading to the left. And then x is less than or equal to 2. I have a closed dot at 2, and I'm shading to the left. And again, we need to figure out where both of them occur. Where are both of them shaded? And it's like over here, there's nothing shaded. And here, only the bottom one is shaded. But if I go over here, both of them are shaded. And that's really what it means to be AND. So that's going to be our solution. So it's going to be anything from 2 that way. And my interval notation would be from negative infinity all the way up to 2. And again, we never include infinity. It's always a parentheses. And 2 is going to have a bracket. And if we turn the page, looking at 5, we have x is less than 3 and x is greater than or equal to negative 1. So less than 3, that's going to be here and to the left. And then x is greater than or equal to negative 1. That's going to be here and to the right. And again, we need to figure out where is the region where both of them are shaded. So over here, only one of them shaded. Over here, only one of them shaded. But if I go to here, both of them are shaded. So that's going to be my solution. So it's from here, and I'm going to take that closed dot, make it closed, and then over to here and make that open. So my final answer is between negative 1 and 3, including negative 1, and not including 3. So negative 1 gets a bracket, 3 gets a parentheses. And then lastly, number 6, we have x is greater than 3, and x is less than negative 1. So greater than 3 is going to be an open dot at 3 and shading to the right. Less than negative 1 is going to be a open dot at negative 1 and shading to the left. Now, if we look at this, over here, only one of them is shaded. Over here, only one of them is shaded. And if we look here, none of them are shaded. So there actually is no region on here where both of them are shaded. So it's like there is no intersection. So it's going to be no solution, or you can put the fancy symbol. So you won't always have a solution. So those are kind of the 4 basic cases. You have this one where it's kind of all the stuff to the rightmost. Here, all the stuff to the leftmost. Here is kind of an intersection in the middle. And here's where they actually don't intersect.